Okay, this is going to be inequalities. This is not a test. Don't worry about the fail, pass, master part of it. We're going to take this for the first time Tuesday right before break. This will be the only one. Okay. It's new. Haven't done it before. And here's what's on it. Okay, well, the first thing we're going to do is we have to solve these. We need a number line to find all the answers because less than or greater than is infinite. Okay, it's not like there's just one. It's a solution set, but the set is infinite. So first off, it's kind of like an equation, except there's one key important thing, couple ones actually. First off, x isn't being multiplied or divided. So if it's not being multiplied or divided, then I can keep that sign the same. The only operation I have to undo is the minus 4. So I plus 4 plus 4. So I'm ready for my solution set. I have x, and then negative 5 plus 4 is negative 1. So x is all numbers less than negative 1. So I put negative 1, circle. I'm not going to fill it in because it can't be equal, only less than. Okay, now my next problem. X, there it is. It's not being multiplied or divided, so that sign for now is going to stay the same as I undo my operations. Okay, the only operation I have with the x is the minus 8, so I plus 8, plus 8. Now, that's obviously 9, but 9's over here, so 9's over here, x is over here. Well, we can't graph that because that's out of order, okay? So then we need to put the x before the 9. It's like a sentence. Then we flip that. Because if 9's less than or equal to x, then x is greater than or equal to 9. Circle, and now you're going to fill that one in because 9's part of the solution set, and so is all the numbers greater. Okay, now, when solving inequalities, here, is x being multiplied or divided? Sure is. Okay. Now, that's first question. Now, the second question is it multiplied or divided by a negative? Sure is. So that greater than now goes to a less than. So to undo dividing, all I need to do is multiply. Remember, multiplication's commutative. It doesn't matter the order. So I kind of like just moving that out of here. That's what happens when I multiply by negative 4. It just gets rid of the division by negative 4. And then we have x where it belongs, and that's 32, positive. So x is less than or equal to 32. Now you can be equal, and then less than goes that way. Okay, the next one. X being multiplied or divided. Yeah, it's being multiplied by a negative 2. Okay, but it's a negative, so we need to change it. We're going to have to change it greater than to less than when I'm ready to identify my solution set. But before we do that, we have two operations to undo. First is the minus 3. Okay, you're not ready for this yet because you still have a negative 2 times operation. Okay, now I can do my division operation. And now I'm ready for my solution set. We have x and negative 5. X is less than negative 5. Circle, you don't fill it in because negative 5 is not actually part of the solution set, only the numbers that have a lesser value than negative 5. Okay, now x appears twice in the inequality. So we want to take the 1 over, and it's on opposite sides of the inequality, so I need to balance the inequality. So minus 3x, I'd plus 3x, and then I would add 3x to the negative 2x. That is negative 2x. So it gives me 4. Negative 2 plus 3 is 1. Sign, and then 7. So now that x appears only once, is it being multiplied or divided? Well, not really, because having a 1 means you're not really multiplying it by anything, okay? So no, that sign's not going to change. Having a positive 1, I should say. So I undo the 4. That's the only operation I have to undo, and that gives me x and 3. Remember, positive 1x and x are synonymous, so 3. Don't fill it in. It just goes that way. Okay, next problem. Well, we got parentheses. That's the first thing. 2 times 4x, 2 times negative 7. It's going to make 8x plus negative 14. And then my sign. That's going to make 8x plus negative 24. Now again, x appears twice in the inequality. So because x appears twice, well, again, it's on opposite sides, so I would normally balance it, except for the fact they're exactly the same. So they balance right out. Now you got to think a little bit more here than if you just have a regular equals, greater than or equal to. Negative 14 is a larger number than negative 24. So the sign should be about ready to swallow that number with its mouth, and it is, okay? So that is all solutions. With all solutions, you are not going to graph. Okay, now the next problem, we have a compound inequality. It means there's 2 of them. So, first off, check your x. It's being multiplied by a negative, so the signs, both of them are going to change. And I know at the end that x needs to be in the middle by itself. I need to undo the plus 9 first, and then undo the multiplication by negative 3 second. So I'm minus 9, but then I need to minus that, subtract that from negative 6 and 21. Now I'm not ready for this yet because I still got the operation of multiplying by negative 3. So that makes negative 15, negative 3x, and then 12. Okay, so now with that being said, I'm ready now to unmultiply the negative 3 by dividing. And now the x is all alone, so I'm ready to fill out my solution set. That's 5, and that's negative 4. Okay, so positive 5, negative 4, and with these, they just go towards each other. You're not going to have any on the assessment where they go outward. I didn't even put any absolute value inequalities on that. Okay, that was just kind of an assignment. Okay, graph the inequality. Well, first off, if that were an equals, this would be in slope-intercept form. Okay, so I'm going to use slope-intercept to graph it. Slope and y-intercept. Slope's negative 3. Now that's an integer, so we put a 1 and then 5, 0, 5. So I go up 1, 2, 3, 4, 5. Then we go down 3, right 1. Okay, but you don't have the little equals under it, so we're going to make a dash line. I got to set the camera down so I can use my ruler or my straight edge. Make a dash line because equals, they shouldn't be equal, okay? So when I draw the dash line, it's like I'm deleting out the points that make it equal, which is what a line is, okay? And then I kind of like to always put the inequality there. Okay, it's not equal to, that's why it's a dash line. Now we got to do the less than part, find the side that's less than, here or here. Now again, the best solution to pick is 0, 0. You can pick anything unless it runs through the point. Okay, so empty your y and x variables out of the inequality and insert 0. There's no operations here, 0, less than. You have a times operation, which is 0, and then a plus 5, which is 5. Now, 5 is larger, and it does eat the 5, so 0, 0 is true. So if that's true, so is every other point over here. And that's false. And again, you don't need to do this, but a textbook would have the true side shaded or highlighted. Okay, now the next one, if that were an equals, that's in standard form. So it's in standard form, I'm going to find my x and y intercepts. Okay, so 4x plus 8y, just put equals when finding the intercepts, okay? So x is 0, get him out. And if y is 0, we're going to get him out. So divide by 8, 16 divided by 8 is 2. and 4. Okay, so 0, 2 is the y-intercept, and 4, 0 is the x-intercept. 1, 2, 3, 4. Now we see we can be equal, so I'm back to drawing just a regular line. Okay, and then Herbson's going to put his inequality, 4x plus 8y greater than or equal to 16. Okay, now the equal part's there. Now we find the greater than portion. So 4, empty those parentheses out, plus 8 parentheses greater than or equal to 16. Now 16 has no operations. That's going to be over there still. Then 4 times 0 is 0, 8 times 0 is 0, 0 plus 0 is 0. Now 16 is bigger, but the sign is not opening up towards 16, making it a false. So then any point over here is false. Any point over here is true. I just need to see the true and the false. Okay, then you have a couple story problems. I didn't really do a very good job explaining this part to especially 6th hour. Okay, I did a poor job. Toys R Us is selling remote control airplanes. They pay the production company Kenner $10 per airplane to bring into the store. They sell the airplanes for $16 each. They'd like to make a profit of at least $500. How many airplanes would they need to sell to reach the profit goal? So a profit is greater than, profit's different. We're going to make a table here, and we're going to put the two words here. We're going to put sell and spend. Okay, use those words, sell and spend. Now our profit's $500, greater than or equal to 500. Now what are we selling the airplanes for? We're selling them for $16 each, so 16x because it's for every airplane. So then I'm going to cross 500. I know that's a profit. I'm going to cross 16 out. And then I spend, I'm going to spend, when I pay, I spend $10, but that's per airplane, so 10x, but anything you spend is a negative. Now these are both x's, so we add those together, okay? 16 plus negative 10 is 6. And all you got to do is divide. The sign's never going to flip on these, okay? Because the whole idea of doing a profit is you're selling for a higher amount, so it won't be a negative. 83.3. So we on the greater than, then you need to go to 84, even though it doesn't technically round. So you put greater than or equal to 84. Okay, sell, spend. Okay. All right, now this one. Graphing inequalities. One bus ride costs 75 cents. One subway ride costs $1. A pass can get you $63 worth of rides. Graphing inequality, I should say, that represents possible combination of bus rides and subway rides. You could go on with the pass. Okay, so let's have this be bus and this be subway, the two things. Now, this is a little different than the assignment we had. I'm the one who's carrying the money with me, not making the money. So this would be less than or equal because we can't spend over that. So a bus ride costs 75 cents. Just make the one that's mentioned first, the x, and then y. Plus, and then 1y. Okay, this is in standard. So we're going to find the x and y intercepts. Okay, so 0.75x plus 1y equals 63, and then the same thing. This is what we did on that late start day. X is 0, y is 0. 63 divided by 163. Divided by 0.75. 63 divided by 0.75 actually takes this up because you're dividing by a number less than one whole. And it goes up to 84. Okay, so y, we got to get to 63. Let's go by tens. Tens, 20, 30, 40, 50, 60, 70. So 63 is about right there. And then 84, 0, we're going to go by tens here. Remember, 0 is in the corners. So 10, 20, 30, 40, 50, 60, 70, 80, 90. So 84 is right there. The line's always going to be solid here. And if you have less than, okay, then the true is inside the triangle, because I can't go outside here. I don't have that much money, okay? It's not like a profit where you want to go outside. False. You don't need to do a test on that. You can just use common sense. Now, there's also, and this is the same standard, absolute values. But I didn't put any absolute value inequalities, so that's good news for you. Okay, absolute value of 6, with distance on a number line. That's 6, and that's 8. 6 plus 8 is 14. First, you got to do the operation within the absolute value. You have negative 3 there and 3 there. So negative 3 is 3 units from 0, plus, and then 3 is 3 units from 0. 3 plus 3 is 6. Operate inside, that's negative 5, and that's 9. Negative 5 is 5 units from 0. And then I subtract, and 9 is 9 units from 0. 5 minus 9 is negative 4. Now, I thought some of you were like, well, I thought it couldn't be a negative. Yeah, it's not inside the absolute value, but once the absolute values are gone, then your subtraction, if it gives you a negative, it gives you a negative, okay? It's just inside the absolute value where the number pops out positive. If you're subtracting outside, then yeah, you could very well get a negative. Okay, there's two answers. You're solving these equations, but if you're talking absolute value, any absolute value has two possible units on the number line. So inside the absolute value, we just have x, no operation with it. And the two places you could be 7 units from 0 is at 7 or negative 7. Two possibilities. It's all about number line. Okay, this time there's some operations within the absolute value. 2 times x plus 5, and 2 times, put that down twice. And the two places you can be 11 units from 0 would be at positive 11 and negative 11. So I undo the plus 5 and then the multiplication by 2. Okay, 11 minus 5 is 6. 2 times x equals 6, so x must be 3. Okay, minus 5, that's going to be negative 16. 2 times x equals negative 16, so x needs to be a negative 8. Now on that one, if you get a never, I'm fine with a decimal, but if it's like never ending, then you need to do your ABC. Now you got some things you need to take care of here before we go to the table. Now within the absolute value, I just have x minus 2. But you have operations outside the absolute value you need to undo. A times 4 and a minus 3. First we undo the minus 3 by adding 3. You got to do that. Undo your minus plus first, and that's 16. So I have 4 times absolute value x minus 2. So I undo the times 4 by dividing by 4. And 16 divided by 4 is 4. So I now have the absolute value x minus 2 is 4. Well, you could be at 4, negative 4 then. Add 2, I get 6. Add 2, I get negative 2. All right, that's what that standard's over.